So in this video today, we are going to go over the 12.3 notes. And so we're going to talk about sampling distribution, surveys, experiments, and observational studies. So first of all, I'd like you guys to pick up a copy of the 12.3 notes on the card outside the door. That's my students, and if otherwise you guys know where your notes are. Grab a whiteboard, a marker, and a cloth under your seat. So I'd like you guys to go ahead and answer this question. What is the percent of data that represents at most a z-score of 1.7? So go ahead and do this. Pause the video if you need to. Give everybody a few minutes to do it and then start the video back up. Okay, so on this one it says what percent of the data, what is the percent of the data that represents at most a z-score of 1.7? So here's the deal. We're going to use second vars, second on our calculator. Whoa, that's pretty ugly, y'all. Second. And then vars, V-A-R-S, which you know on the top of that says distribution, right? And then you're going to push the 2 key, okay? So then we got to get a lower bound, an upper bound, a mean, and a standard deviation, right? So it says what percent of this the data represents at most a score of 1.7? So at most means, so there's our 0, right? And 1.1 would be there, 2, 3, right? 1, 2, 3. And then over here we have -1, -2, and -3, okay, on a z-score. That's how we create our normal curve, right? So if it says at most a score of 1.7, that means we're talking about a score over here somewhere, right? And if it says at most, then we're going this direction. So what's our lower bound going to be? -1,000,000. And what's our upper bound going to be? It's going to be that 1.7, isn't it? And then remember, our mean is our mu. That's going to be 0 right there. And our standard deviation is going to be 1 because we're moving 1 at a time to the right and 1 at a time to the left. Okay, so go ahead and put this in the calculator if you have not already done so and see what the answer is. Okay, so now when I'm looking at this, this is what I recall. So this is 50% of my data, right? So it can't be this one, and it can't be this one, okay? And then this would be another 34, and this would be, this whole space right here is what, another 13.5, right? So I know it's going to be at least 84, okay? So it couldn't be this one either. So I could actually have done this without even putting it in the calculator. But the answer was B, okay? So I'd like to make a couple announcements to y'all. So first of all, we have a quiz next Thursday. And it's going to be on SchoolNet. We have a Delta Math Week 17 that was assigned yesterday and it's due next Thursday. And the last day to turn in NTIs is next Friday. That would include all your digital learning day assignments and your Delta Math. And we will have our usually scheduled tutoring next week as well. So here's the notes for today. When a survey is used to gather data, it is important to consider how the sample is selected for the survey. So if the sampling method's biased, the survey will not accurately reflect the population. So you guys have read, those are your blanks in your notes, okay? So most national polls that are reported in the news are conducted using careful sampling methods in order to minimize the bias. Other polls, such as those where people phone in to express their opinion, are not actually usually reliable as a reflection of the general population. So if you guys need to pause the video here to write down the words, go ahead. All right, so remember that random sample is one that involves chance, so 6 different types of samples are shown below. The first one is a simple random sample, okay? So members are chosen using a method that gives everyone an equally likely chance of being selected. So an example of a simple random sample would be all students' names at Archer High School are put into a box and drawn, and we draw out 100, okay? So we're going to type that up. So all students at Archer, we'll just say AHS. Actually, let's say all students' names at AHS are put in a box and it'd be great if I could spell, huh? Drawn. And we draw 100 out, okay? So So the next one over here is called systematic sample. So this is when members are chosen using a pattern, such as selecting every other person. So this time we could just say that our pattern is going to be selecting every 10th person, right? So instead of, again, putting them all in a box, we could say every 10th person, okay? All right, our next one is stratified. So the population is first divided into groups, then members are randomly chosen from each group. So when we talk about stratified, on this one, we're going to basically break them up into groups of like 9th, 10th, 11th, and 12th graders, right? And then we're going to choose 100 from each of those grades. So we're going to say 9th, 10th, 11th, and 12th. Choose 100 from each group, okay? So that's how we're going to do this one. Our next one's cluster. So this is the population is first divided into groups. Now these are very similar, stratified and cluster, okay, but there's a little bit of difference. So with the cluster, the population is first divided into groups, but then a sample of the group is randomly chosen. So all members of the group are surveyed. So on this one, we would basically say, we're going to break them up into groups, yes, but we're only going to survey the 9th graders, right? So we're going to survey all of the 9th graders. So now let's see if we can figure out what are the differences between these two. All of 9th graders. Pretty great if I could spell, y'all. All right. Okay, so difference here. Stratified, we break them up into groups, and then we choose the same number from each group, whereas the cluster, we choose a group, and we survey all of the people in that group, okay? So our next one's convenience. Members are chosen because they're easily accessible. So this one would be like, I'm going to survey the people in my class. So we'll just say we're surveying Mrs. Jones' classes only, okay? And that's because I'm the one that wants to pull the data, okay? Now the last one is what's called self-selected, okay? So on this one, it's members volunteered to participate. So basically, they choose whether they participate or not. So they choose. So this is like, I'll give you an example. So say, for example, you go to Chick-fil-A, and on your receipt it says, take the survey for a chance to win, okay? That's self-selected because you are choosing to respond, okay? All right, let's go to the next page now. It says, example 1, the officials of the National Football League want to know how the players feel about some proposed changes to the NFL rules. They decide to ask a sample of about 100 players, classify each sample. So the first one is the officials choose the first 100 players who volunteer their opinions. So what is this one, y'all? So look back up at the ones that are there. See if you guys can tell me. Yep, this one is self-selected. Okay? Because the players volunteer. Okay? That's the key right there. They volunteered. So the next one is the officials randomly choose 3 players from each of the 32 teams in the NFL. So 3 players from each of the teams. Okay? So this one is stratified. Okay? Because the population is first divided into groups, the 32 teams, and then the members are chosen from each group. Okay, now C, the officials have a computer generate a list of 100 players from a database that includes all of the players in the NFL. So, oh, by the way, let's look at the differences here. So on this one, the last one was first divided into groups and then choose from each group. Y'all see that? That's the keys there, okay? So the next one, it says again, the officials have a computer-generated list of 100 players from a database that includes all of the players in the NFL. Notice that, all of the players in the NFL. So this one is going to be a simple random sample, okay? So this one's going to be simple random because it includes everybody, okay? And then 100 players from everybody are pooled. So let's see if you guys can do these 3. Actually, we'll do them one at a time. So go ahead and do letter A. So it says the campaign staff for a state politician wants to know how voters in the state feel about the number of issues. Classify each sample. So the first one says they call every 50th person on a list of registered voters in the state. So go ahead and pause the video. Everybody answer this question and come back to me. So this is going to be a systematic sample, okay? And why is it going to be a systematic sample? Because the definition here was members are chosen using a pattern such as every blank people, right? And this was every 50th person. Y'all see that right there? So that's how we know this is systematic. The next one says they randomly select 100 voters from each county to call. So go ahead and choose this from your list. You can pause the video if you need to. All right, so this one, they randomly select 100 voters from each county to call. So this is stratified. How do we know? So this is stratified study or sample because they randomly select 100 voters from each county, right? Each county. That's key right there, okay? The last one, they ask every person who comes to the next campaign rally to fill out a survey. Again, you can pause the video here, let people answer, and then come back when everybody has. All right, on this one, this is going to be a convenience sample, right? Why? Because they're only surveying the people that came to the next campaign rally to fill out the survey, okay? So the sampling method chosen should consider accuracy and budget. So usually the more accurate samples are, the more expensive they are, okay? So of course the best would be a census where every individual in the population is in the sample. This is always your best, okay? Census. So the census is always your best, okay? Then when we're talking about the most accurate, we got simple, random, stratified, and cluster, and then our not very accurate are convenience and self-selected. Now I noticed, I don't know if y'all noticed, but I noticed that there's one that's not on here. So it's kind of between very accurate and not very accurate, and that would be our systematic sample. So I'm going to put it right here. So we're going to actually number these, okay? So our most accurate would be simple random because, again, we're doing this, it's very random, okay? Stratified, if you recall, is we are surveying the same number of people in all different types of groups, okay? So this would be our second most. And then cluster is basically doing a group of people, okay? So honestly, these two right here, I might actually put systematic above cluster, okay? So I might say that this one is 3 and this one is 4, because if you remember, cluster is a group of people, whereas systematic is just every so many people, okay? Convenience sample would definitely be 5, and self-selected is always the worst, okay? So if they are selecting to participate in the survey themselves, then that is always the worst kind, okay? All right, now we're going to read through this problem, this example. A high school student has 552 freshmen, 495 sophomores, 449 juniors, 439 seniors enrolled. The student newspaper wants to take a survey of the school. So this asks us to classify each sampling method and then determine which is most accurate, which is least, and explain our reasoning, okay? So, we do randomly selecting 50 freshmen, 50 sophomores, 50 juniors, 50. So we notice a 50, 50, 50, 50, right? So that's going to be stratified, right? That's going to be our stratified sample. We're just going to name these first, and then we'll determine which ones are most accurate. Randomly select 200 students from the complete roster. So this is going to be simple random. Okay, and then our last one here says choose every 10th student who enters the cafeteria at lunchtime. So this is going to be a systematic sample, right? Okay, so let's just think this through. I told you guys simple random is always the most accurate. So this is our most accurate, right? Now let's see if we can figure out which of these other two, stratified or systematic, is going to be more accurate. Systematic is choosing every 10th person that came into whatever the lunchroom, right? Whereas when we do stratified, we got 50, 50, 50, 50. So our least accurate is going to be systematic, right? This is least accurate. Because it told us to say which one was most and which one was least. Whereas stratified is going to be in the middle, isn't it? So simple random is our most accurate, systematic is our least accurate, stratified would be in the middle of those two, okay? So go ahead and do this one and come back to me when you are done. Pause the video and come back when you're done. So you're going to choose what type of sampling method was used, and then tell me which one's more accurate and which one's least accurate. Pause the video. Okay, so it says a small town newspaper wants to report on a public opinion about the new city hall building. Classify each sampling method. We're going to do that first, then we're going to determine which one's more and which one's least accurate. So this says ask readers to write in and give their opinion. So, this is self-selected, y'all, because they get to choose, right, whether they're going to respond or not. So this is self-selected. And then survey people who come to the next town meeting. So this one's going to be convenience, right? So of these two, which one is more accurate? It would be this one, right? This would be more accurate because we at least surveyed all the people that showed up to the town meeting. Now, the other one is, if you have an opinion, I mean, some people will write in, some people won't, right? So this is going to be the least accurate of the two. Does everybody understand why? It's because they get to determine whether they actually respond or not with method A, okay? So as we move on, there are different ways of collecting the data. There's surveys, experiments, and observational studies. These are some of the examples. So when we talk about so we've been talking about surveys, right? Okay, but now we're going to talk about an experiment and an observational study. So an experiment imposes a treatment on an individual to collect data on their response to the treatment. Okay, so we are looking at treatment here. Actually, I'm going to do this in a different color so y'all can really see it. A treatment on an individual. So an example of that is a researcher adds acetone to gasoline to measure its effects on fuel efficiency. So then when we're talking about an observational study, it's when they observe individuals and measure variables without controlling the individuals or their environment. So that's without control. Y'all see that right there? A researcher wants, here's the example. A researcher wants to find out if poor nutrition affects eyesight, but it would be unethical to deliberately subject someone to poor nutrition, right? Because it may actually cause problems with their eyesight. So that's when we would do an observational study, when it's unethical to cause deliberate harm to somebody, okay? All right, so now we're going to look at some examples here. So the first one says, explain whether each situation is an experiment and observational study. So the first one says, a researcher asks students in the average number of hours of sleep they get per night and examines whether the amount of sleep affects the students' grades. So let's, first of all, you notice this word asks. So the researcher asks the students and does what else? Examines whether the amount of sleep affects the student's grade. So what do you think? Do you guys think this is going to be an experiment or an observational study? It is. It's an observational study. Because we don't have any control here, do we? So this is observational. All right, the next one says explain, again, the situation. Is it an experiment or an observational study? So a park employee wants to know if latex paint is more durable than non-latex paint. So she paints 50 benches with latex paint and 50 benches with non-latex paint. So do you notice that we have the same number of things that we're doing, the same number of items, the benches, that we're doing different things to? So this would be what we would say is an experiment, right? Why? Because we have the same number of items that we're doing different things to, okay? To different treatments. So let's see if you guys can do these next two and then come back to me when you're done. Pause the video here. So this one says a researcher wants to know if a soil additive makes fern grow more quickly. So he grows one specimen in treated soil and one in untreated soil. So notice we have one specimen in treated soil, one in untreated. What do you think this is going to be? Yep, an experiment, right? Because we have control here, right? We have one that actually has the treatment and one that doesn't. Okay, here's our next one. To find out whether car accidents are more likely on rainy days, a researcher records the weather conditions during 50 randomly selected accidents for the past year. Pause the video if you guys have not answered this already. Okay. So let's look at for some words here to find out whether accidents are more likely on rainy days. Okay, so this is an accident, y'all. So are we going to cause accidents? Are we going to control whether an accident happens or not? Right. So we're going to talk about 50 randomly selected accidents, right? But this is going to have to be observational. Why? Because obviously you could cause harm to a person in a car accident, right? So it's logical. If you can cause harm to somebody, it's always going to be observational, okay? All right, for data from an experiment to be useful, the experiment must be carefully designed, okay? So in a controlled experiment, 2 groups are studied, okay, under identical conditions except for one variable. So in randomized comparative experiment, the individuals are assigned to 2 groups randomly. The control group, key here, control group, which does not receive the treatment, and then the treatment group, right there, which does receive the treatment. Okay, got it? So when we have a treatment group, they receive the treatment, and a control group does not. This is how we're going to determine whether the treatment is doing what we expect or not. And it allows us to accurately compare whether it is effective or not. So here's an example. The study describes in the report is randomized comparative experiment, describe the treatment group, and the control group. So to test the redesign of a website, an online bookseller assembled 96 users of the site and randomly divided them into 2 groups. So we got our 2 groups, right? So we know it's going to be an experiment. One group used the new website to make online purchase, and one group used the old website to do the same transaction. Users of the new website were able to complete the purchase 22% faster. So as we look at this, our treatment is using the old versus the new, right? So the treatment group used the new website to make the online purchase, whereas the control group used the old website to make the online purchase. So again, our treatment is using the old versus the new. It asks us to describe the treatment. And then the groups were treatment group was the new website, whereas the control group was the old website, okay? All right, randomized comparative experiments also allow us to make valid cause and effect conclusions. So these experiments are also very reliable. They can be repeated over and over again and get similar results. So sometimes conducting an experiment would be unethical. Can you think of an example? So think about something that you would do to a child. That would be unethical, right? So if you deprive them of sleep or food or anything that would be harmful to a person would be typically considered unethical. So in a case like this, you should obviously use an observational study, but you should still have randomness because otherwise you are affecting the outcome. All right, so example 5 says, explain whether the research topic is best addressed through an experiment or observational study, then explain how you'd set it up. In whichever way. Okay, so this first one says, does listening to an MP3 player, we could say iPod, not iPod, but an iPhone or however you listen to music, okay, with earphones for more than an hour per day, does it affect a person's hearing? So think this through. Should we make this an experiment or an observational study? I would say observational. Choose people who do and do not listen to more than 1 hour per day and monitor their hearing. Why would we not make it an experiment? Because it could cause a detrimental effect or a negative effect on people's hearing, right? Okay. So here's our next one. This one says, do people who consume 100 milligrams of vitamin C each day as a dietary supplement have lower cholesterol levels than people who do not consume vitamin C supplements? So let's think about this one for a second. So on this one, I would say this could be done as an experiment. Vitamin C, 1,000 milligrams of vitamin C is not known to have any negative effects on people. So if we conduct the experiment, we have to randomly choose one group of people to take the supplement. That would be our, treatment, right? And then randomly choose another group of people to not take the supplement. That would be our control group, and monitor the cholesterols in both, okay? All right, let's see if you guys can do this one. Does using tanning beds at least twice a month affect the likelihood of developing skin disease? So first of all, tell me whether you want to do this observational or experimental. And then why, okay? And how you'd set it up, basically. So I would do observational. Why? Because the treatment may cause them to get skin cancer, right? So it's not ethical to assign individuals to a treatment group. So we're going to perform an observational study. We're going to randomly choose one group of people who already use tanning bud at least twice a month and another group that does not. Monitor the incidence of skin disease in both groups, okay? All right, so this is our last example, and you try. So this says a researcher is considering 3 methods of evaluating 2 different cold medicines. Tell whether each is a survey, an experiment, or an observational study. Then explain which method would be most reliable. So let's look here. This says choose 50 people at random. Ask which cold medicines they have taken in the past and how effective they were. So what do you guys think? Do you think this is a survey, an observational, or experiment? Let's look at some key words here. So I would say that we're asking, right? Which we're choosing 50 people at random. So I would say that's important. We're choosing 50 people at random, right? Then we're asking which cold medicines have in the past been effective, okay? So I would say this is a survey. Wouldn't you guys? Be great if I could spell. Okay, let's talk about this middle one. Monitor 50 people with colds and measure the length of symptoms for the individuals who choose to take each type of medicine. So what do y'all think? Is this going to be experiment or observational? Monitor 50 people with colds. Measure the length. Y'all with me here? So monitor is important here, right? We're measuring the length of people who choose to take each type of medicine. So this is observational, isn't it? We don't have a control group, do we? Okay, then this last one, randomly divided people groups, divide them into 2 groups. Key there, right? Give each group a different medicine measured length. Okay, so this is definitely our experiment, right? And then it says which one is going to be most reliable. That one right there, experiment is always going to be the most reliable, okay? So if you can differentiate the 3 of them, then experiment's always going to be your most reliable. Okay, let's see if you guys can do this. You try. Pause the video here. Tell me which one is a survey, experiment, and observational study, and then which one is most reliable again. Okay, so randomly choose. Method A is randomly choose 50 people to exercise 3 hours a week and 50 people to participate in another activity and monitor their health. So we got 50-50, right? And we're going to still monitor their health, right? Is this going to cause them any harm? No. So we can call this an experiment, right? All right, a middle one. Randomly choose 100 people. Ask how many hours a week they exercise and how healthy they are. This is going to be a survey, isn't it, y'all? Now remember, surveys have the least amount of control. Then method C, choose 50 people who exercise regularly and 50 people who do not. So here we notice we got them in 2 groups, 50 people who exercise and 50 who do not. So this is going to be our observational study, right? And which one is always going to be more accurate? It's going to be the experiment, right? I just said this already. So it's always going to be your experiment.